Okay, so this is the third part of the bushwalking through the Valley of Vectors. It's Rose and Jess. You also go off on a book walk separately. This is Rose's position vector, and that's Jess's position vector. They had lunch at their destination points, and n only goes from 0 to 3. Express the distance between their lunch positions in terms of n. Well, if this is OR, and that's OJ, then this here is the distance between their lunching destinations. So I'm looking for RJ, and RJ is going to be this negative plus this, so negative 9n plus 7 plus this negative, so that's negative 3n plus 1 is minus 3n, 1 plus 1 in the j, and then 0 in the k. So find the distance, so that's going to be a minus. So the distance between them will be the square root of minus 9 plus 7 squared plus minus 3 minus 3n minus 1 squared. So that is going to be the square root of 10 9n squared minus 12n plus 5 is the distance between them in terms of n. How far away when n equals 0? So if I take that and make x equal 0, I get 5 root 2. Find the values of n that has the girls closest together and furthest apart. Okay, so what I'd like to do is I'd like to have a little look at this. I know that n goes from 0 to 3. And if I take this and I drag and drop it, and then go zoom auto, and if I do analysis, GSOL minimum, I can see there is my minimum, 3.16, and that's at, looks like 2/3. And analysis, GSOL F max should be at 3, and it's 22 point something. So the values of n, what values of n has us closest together and furthest apart? Well, n equals 2/3 will when they'll be closest together, and n equals 3 is when the girls will be furthest apart. I mean, if I take this expression and find out what the exact distances were, even though the question didn't ask it, calculate F min between 0 and 3. And the minimum distance is root 10. And that's at 2/3. And if I look for the maximum distance, it's 10 root 5 at 3.